Okay, so we're going to do that thing that we were talking about. So for the two people using Mac and work in progress Rhino, you guys are going to have to use the pipeline. It works exactly the same, like layer and type and name are in that pipeline, but it's just instead of typing point, you have to select double click point, curve, brep or mesh, etc., etc. Okay, but for everyone else, we're going to use human, and the key reason is that I can actually type two layers in, and it will pick up both those layers at the same time instead of having to copy and paste the geometry pipeline twice. Okay, so what we're going to do is we're going to hide all that stuff. I'm going to delete all of this stuff. Is just to be sure, is everyone clear on that little work, like that test almost that we did in the lecture? Is everyone clear on what that was trying to prove? More so, is anyone unclear of what that was trying to prove? Okay, so everyone's clear. That means I'm not going to expect any emails from you guys about it. With the what? What was the original issue? It doesn't preview? Okay, well, in your case, if you, in any Rhino command, so if you were to type layer, it should show the layer panel. I know you can't really see it. You can, okay. But if you type negative at the beginning of any command that has a dialog, so for example, save, panel, properties, anything like that. So if you type minus and then layer, then it will allow you to type in the commands instead of using a panel. I honestly don't know why your computer's freaking out so much with that. Maybe I can spend some time looking at it later, properly. Either way, you're drawing everything, you should be drawing everything on the default layer, and you can see at the bottom here, you can actually change the layer that you're drawing on with this little thing here too. So like at the very bottom. So what layer are you drawing on at the moment? Default. Okay, so I'm gonna do everything on default at the moment. For those of you who can add and change layers, please do so. But yeah, you're obviously limited to default and layer 1, 2, and 3. So I'm gonna draw one room outline. I'm just gonna make sure I'm in meters, because I don't want to work with large numbers at the moment. And if we were gonna write a script that works for this system, we never want to work with one object, okay? Because the instant we work with one, we end up scripting for one. And remember how we did like one segment and we ended up drawing the lines between those two curves? And the attitude that you have as you're going into that is very much, oh, I'm only like doing this once. And so you see there's a very different way of coding doing it once versus doing it lots of times. So when we draw these slab outlines or room outlines, we want to be working with at least 2, okay? You can work with 3 or 4 or 5, but we never want to work with just 1. The other problem is sometimes you'll put stuff into your scripts that work with 2 items, but then when you actually only need to work on 1 item, the script doesn't work. And we might address those problems later in the semester, okay? Okay, so we've got 2 curves on the default layer. So I'm gonna go and grab human. I'm gonna go and grab the dynamic geometry pipeline or the standard geometry pipeline. And we're going to input into that default or whichever layer name that you're using. Oops. we're going to grab curves, or curve, I think, just curve. And we don't really care about the name. Eventually we might care about the name. We might grab some information about names later. Like for example, we want the living room to be a lot taller than the bathroom. So we might put some names on this thing and actually have it changed based on what we type in. Do you need glasses, man? Okay. It's just the look that he was looking at the screen and it looked really funny. Pardon? You put a panel in and you type curve. It comes up orange. Have you actually drawn curves in the default layer? Has it been in? Hey, Julia, do you mind? Thank you.
Did I use this one?
No, it's here. Okay, so is everyone clear? We've got 2 polylines coming into our system. Now, Grasshopper's super dumb, right? So if I drew this curve, it's also going to pick that curve up. But is there a problem with that curve versus what I've drawn? It's open, right? Now, do we want to rely on us to be diligent and never draw an open curve? Or do we want to write into the script a check? What is she using? It's okay. Hang on, let me just come check. Ooh, that's fine.
Because if you plug in your curve panel, then draw the curve, it doesn't work.
Can you click this? No, it does work.
It didn't for me.
Is that on default layer? Can you make these? Hang on. How did you spell curve? Okay, now right-click that.
What?
Right-click it and make it multi-line.
Oh, it's not.
And then right-click that and make it multi-line.
Okay, that will be a rock.
Okay, guys. Just to point out, some of you may do this. Some of you may do this. Default, enter, okay. And then it stops working, okay? And that's because when you've got a panel, that panel actually, it records the enter. So if I then type enter again in 4, you can see it's actually picking up the fact that there's an enter. So we just need to make sure, like we can be very sure that this is working. If we right-click these panels, set multi-line data, what that does is it just makes sure that you don't have hidden characters in the panel like enter or potentially space bars. Yeah? Cool? That's why it wasn't working? Cool? Okay. You right-click the panel and you turn off, you turn off multi-line data. You're welcome. Cool. Okay, so now what that also means is you can use panels to enter 1, 2, like actually put lists in. That's obviously not a list, but if you right-click it and turn off multi-line data, you've now got a list. Yeah? Is that the first time anyone's shown you guys that? Okay. So, should we be writing into our script a check to see if there is closed or open lines, or should we be diligent and never put in closed or open lines? That's a good answer.
Better safe than sorry.
Yes, better safe than sorry. The key thing is, if you start writing into this your logic, right? So if you know that you can't turn that into a floor slab because it's open, but you're working with someone who isn't necessarily the brightest tool on the shelf, and that happens a lot, and they don't really care or understand that lines can't be closed or open, then it's worth putting this system in so that you don't have to constantly check their work, okay? So, yet again, this is going to be a softball. If I want to find, I'm actually going to throw this question to Sophie. Sophie, if I want to check if my curves are closed, where do you think I can find that component?
I'm still not familiar with all.
I know, but you should be able to answer this question. Check the tabs. Which tab do you think it will be in? Yes? So if we go into curve, which section do you think in curve we can analyze whether or not a curve is open or closed? Right. Now if I open analysis, which component do you think it is? Yes. Okay. I'm gonna hound this into you guys. Everything that you need to know on how to use like these components is there. It's intuitive. It's there for you to use. Like they've organized it in that way. So, please go exploring. If you think you want to do something, you could probably find it.
Tell them how to, when they type and they don't know where to find it, the reverse way to discover words.
You mean like this? That way? So if you've got if I've given you a script or you've downloaded a script, or let's say last week you put something in, and seeing as all of you have completely forgotten what the matrix thing that I said last week, you've forgotten this week, what you did, you can hold Control Alt, and if you hold down on the component, it will show you exactly where you can find it in the ribbon. Cool. You already knew that though. Huh? Control Alt, and then you click the component. Whoa. Okay, so what output do we get when we test whether or not our curves are open or closed? What output do we get? A Boolean output. Now, last week I explained to you guys the very basics of patterning with dispatch and weave. Okay, so with dispatch, you know where I'm going. Yeah, with dispatch we've got a pattern of true, false, true, false, true, false, and in a list of points we were putting points out as like A, B, true, false. So the first one, and every even list of point was going into one list, and every odd point in the list was going to the second list. Now, dispatch can also be used in a very different way. Very, very differently. Instead of creating a pattern to define whether or not something should or shouldn't go into a list, we can ask the dispatch list to test on a condition and then do something to it. So this comes down to if-then statements. Everyone here who has learnt Python should be aware of if-then statements or if-else statements. No? Right, okay. You guys should be within the range of 17, 18, 19. If you are under the age of 18, put your hand up. Okay, if you're under the age of 19, put your hand up. Was anyone who was 18? Is anyone here 18? Right. Okay. So you understand what you were correct. Okay. So what we actually did was we tested what your age was, and for each of you, those of you who are under the age of 19, let's say you were assigned true, right? And then you ran a function on your arm to put your hand up, okay? That's an if-then statement. So what we could do is we could say, if you are closed, if the curve is closed, then turn it into a slab or turn it into a room. So what we've done is we've tested if the curves are closed, and we've got a false and true as the outcome. So if we actually use a dispatch with this, and we use this a false true true pattern in the P input, and we use our curves for the list input there, then true relates to A. So all the curves that we want to turn into rooms should come out of A. And then all the curves that we do not want to turn into rooms will go to B. Does this make sense? Too fast? Jim? Pardon? It didn't work. Drat. Are you sure?
So like everything's fine and you know how there's like a line from A to geometry, right?
That's because you're putting your text into L, not your curves.
Oh, so you want this?
Yes. No. Yep.
All
Perfect. Guys, why don't you move your tables? All these tables are on wheels. Like, I'm sure these two would be more than happy to move the table and that you guys sit on the table. Okay, so is this making sense? Is this making sense? Tom, is this making sense? Okay, so do we understand? Like, for example, I could say if you are closed, then draw a boundary surface, and we've now it's now done a boundary surface for those particular curves. So no matter what I draw now in this layer, if I draw a closed curve, it's going to make a boundary surface, and if we draw a open curve, it does nothing to it. Sweet. Okay, so when you have an if then, guys, when you have an if then statement, when you have if then statements, you can also have else. So, for example, if you are under the age of 19, put your left hand up. If not, else, put your right hand up. So now everyone who is over the age of 18 or 19 will put their right hand up. So I'm definitely over the age of 19. Yeah. So the key thing here is dispatch. Dispatch allows you to do that. Everything that is true comes out of A, and everything that is false comes out of B. Sweet. This is something that you should have learnt last semester. Okay. So, when we draw our room outlines, let's think. There's actually 3 things that we want to do with these room outlines. What's the first one? We want to think of the elements that define a room. What's one of the first? Walls. Okay. What's the second one? That's yes. What's the answer? I see an arm up. That means you have an answer to a question. Hey, I've forgotten her name. Yes, Charlotte. What was the answer? You had your arm up. Right. Okay. What else? We have walls. What else? Rooms. The roof. The ceiling. Ceiling. And what's the last one? The floor. Okay. So let's just think. If we were to define a wall, what are we going to do with our lines to define that wall? We're going to offset them. Now, which direction are we going to offset? Huh? So it sounds like you're undecided. Some people want them to go out, some people want them to go in, some people want them to go either. Do you guys want to, let's write it so that you can choose? Because sometimes we also want lines to define the center of a wall instead of the edge of a wall. Okay? So, let's get rid of this boundary surface, and what we're going to do is we're going to send this geometry off to the wall section. Let's make this the wall section. Walls. Hello, Alan. How is sleeping in? How's the sleep in?
Well, you call it sleep in if you slept, right?
Yes.
Then it was good.
That's good. Okay. Walls. What's the first step? You guys tell me how to script this. Offset. Okay, let's offset it. What type of offset do we want to use? Now, maybe this is a really good time to explain what the difference between these two offsets were. Did I actually explain this or not? Did I?
I just explained to a couple of them, but I don't think you ever explained.
Have I explained what the difference between the two offsets are to everyone? Okay. The difference between these two offsets is one basically takes the control points of the curve and moves those points inwards or outwards. And the other one actually creates a uniform curve, a curve that's uniformly distant from that curve. And as a response, if it collides or if it creates an island, then it will eventually, it will actually trim it. So I will, the Michelin Man figure 8 is actually a really good example of this. So when you offset loose, what it's actually doing is 50. Is it grabs the control points and it slides them in a direction out, right? And so that looks like for circles, it looks terrible, right? Is it closed curve? Yep, it's closed. It moves them out, right? And as it comes in, you'll note that it will actually collide with itself. It doesn't actually care what the outcome is. Like, see how it collides with itself? It doesn't matter, it just moves the control points. And you end up with these two offset. The other offset, what that does is a uniform offset. As we can see here, we get a nice clean output, and we can get, I don't know why this is breaking. You will eventually get islands, okay? Now this really confuses me why it's breaking the system. Okay. The key thing here is, and I'll do it with non-curves. Boolean. That it can create more than one curve. Why is it breaking? Have you ever seen this? The key thing is, when it is working, you can potentially create islands. So you can see why you would have two curves as an output. And that's why when you use this specific offset, it will branch, it'll put these curves into branches. So even if I have two curves here and I offset with this, it's going to put the outcome of these into two separate branches no matter what. So the reason it does that is that if it can have more than one outcome, it needs to know how to group those. It needs to know which particular item that went in is grouped in those branches for the output, okay? The key thing here is we probably actually want to use offset, this specific offset for our walls. Now, let's create a system that allows us to move between doing a center line, an inner line, and an outer line. What what would I need to do to draw a centerline offset? So if I wanted to create a 1 meter thick wall that was offset in both in both directions, so one goes one way and one goes the other, what do I need to do to my offset to make sure that I can get that centered? Not quite.
You divide the distance by 2 and minus 2.
Yes, exactly. That's exactly what you would do. So you could have two offsets. You would create an expression on the first input. And what we're going to do is we're going to change that number. So it's always going to be negative x divided by 2. Yep. And then the expression on the second one would be x divided by 2. So now, whatever width that I put into this, it's going to define that as a center line. That line is now a center line instead of a an edge. 10. Cool? So, just remember, expressions that go into components like this, they can also be written with the expression component. So we could say minus x divided by 2, and we could get that same output. So with 10, we would get minus 5. So using expressions, we can actually start to define whether or not we're dealing with a center line, an inner line, or an outer line for our walls. So with that, we would have negative x divided by 2 and x divided by 2. If we wanted to move between the halfway point and an edge point, we need to define whether or not we go to minus x divided by 1 and x divided by 1. Or we could do what Alan suggested and use a domain. Should we use a domain? You like this way better? So what would I have? I would have to turn the offset of, we could also write this another way. We could write this as times 0.5 and times 0.5. So if we wanted something to go the whole way, what number would it have to be timesed by? If you had to times a number by a number and we want it to be that exact number, what number do we times it by? Right. And if we want it to be half that number, what do we times it by? By, point what? 0.5. And if we want that number to be nothing, what could we times it by? Okay, so all we need is a number that goes between 0 and 1, right? Let's just work on the positive number. When we want this to be full, positive, we would go x times y, right? And so what we're actually looking at now is 10 times 1. Yeah? That's going to work. So now at 0.5, it's going to be 5. And at 0, it's going to be 0. But on the opposite scale, we need the negative to be like the y needs to be negative of it, almost the negative of itself. And when I say negative, I mean the opposite. Negative is probably the wrong word. Huh? The remaining part. So what we could do is we could say minus x times 1 minus y, right? And what that's going to give us is the remaining distance between the positive number and the negative number. So now if I just quickly get rid of my expressions, because we no longer need these. we can change the width of our system, and now this is obviously going in. If I change the position, it changes how that line defines where the wall is being defined from. So at 0.5, it is a center line. At 1, it is a line that then gets extruded out, offset out from that. And if we set it to 0, it's a line that gets offset in. Does that all make sense? Okay, we're using maths finally. Yay, maths. Yeah. Who knew that the 0 and 1 could be so effective? Does that make sense? It does make. You said you were confused. Okay. Okay, that's fine. So, we've now got two lists. We put 2 flat lists into the system, and they're coming out in branches. And the reason they're coming out in branches is because we're using the offset component. And that offset component will always take every input that goes into it and turn it into a branch. Okay? This is actually really useful in this situation because when both of these systems branch at the same time, we can at least think of those 2 curves as being in the same group. Okay, so the inner curve is always in the same group as the outer curve. So if I were to merge those 2, we can see, because they've got the same branch system, we get the same outcome. Just consider when you use merge, everyone's played around with merge at least. Yeah? This is where things get a bit, it gets important when it comes to understanding about branches. Even though I've got these 2 branches, they're in a nice, what looks to be a 2-dimensional list. If I simplify one of them, we get, see how these 2 numbers, these 2 branch numbering systems are different? You see how they're different? That means when you merge them, they don't actually merge together. Okay? So right now, I just want you to consider that if you're trying to merge 2 things and that they're not being merged together, the potential is that you just need to simplify both of them so that they do. Okay, so that their branch numbering is the same. It needs to be, you need to be comparing apples with apples, not apples with apples on top of apples with oranges. I'm going to show that another week because we'll get into that. We're just gonna consider that because the thing is, Grasshopper doesn't necessarily care sometimes about branches, and sometimes it does. And in this case, it does care about branches. So when you merge those 2 together, you just need to make sure the branch numbering is the same. Okay? And to do that, you can simplify. Cool. So that allows us to turn our merged curves into a a boundary surface, like so. And then we can extrude these walls by height. So let's say we want, now I've been drawing this as a super weird scale. So let's just make sure that is roughly 5 meters. And we're going to make our wall like 0.3 meters, a thick wall. So now when we extrude this, what height do we want to extrude this at? Pardon? Anyone? Have a guess. What height would a room normally be? I'm hearing 3, 4. Let's make it a slider. 2.5 to 4. Pardon?
3.1 at least. 2.5.
It could be an office. Okay, so key thing, okay, let's not argue about how high a room should be. It depends on how much money you've got. But, so the key thing here is that as we slide this, we can define every room as having a height. Yeah? Cool. Okay, so let's be really generous. Well, not really. Let's be semi-generous and make a 3.5 meter high room. So the really cool thing about this is as I add curves to the layer, I get walls. What? Sure. So as I draw lines on Grasshopper, I get walls, and as I draw non-open curves on Grasshopper, I get nothing. Okay? Is this like mind-blowing? Okay. Now, if I was to draw a slab relative to these walls, where should I be drawing a slab to? A slab. Is everyone familiar with a slab? What a slab is? I'm not talking about beer. No. Slab, a concrete slab. That's what we call the floor normally. We normally call the floor a slab. Or it's just another term that we use. The key thing is if you make the floor out of concrete, it's a slab. If you make the floor out of timber, it's not a slab. But okay, so let's make this out of concrete. Okay, what curve do we want to define it by? So you got to speak up. The inner? The outer one? Shall we use the outer one? Okay, so if we're doing concrete floor, let's use the outer curve. So I'm going to quickly put in floor. And with the floor, we're going to use our outer curve. Okay? Now, who is familiar with their offsets going all over the place? So, for example, I'm going to draw two rooms. Here's one room, and here's the other. And we're not going to use the center line. Okay, so these are the same curves and they're in the same system, but one room is bigger than the other. One room has the curves going outwards, the walls going outwards, and the other room has the curves going inwards. Does anyone know why that would be? Huh? These two rooms have the exact same curve, like in terms of its dimensions. Okay, but one of the walls is going outwards, and the other one has the walls going inwards. The expression of the offset, but they're actually, just consider this, we're using the same script to offset both. Okay, so I haven't copied anything. It's the same rule is getting applied to both. So there must be a condition somewhere that's making one go outwards and the other one going inwards. Can anyone think of what that condition would be? Yes, it's the direction of the shape. If a shape is clockwise, it's going to offset one way with a positive number, and if it's counterclockwise, it's going to offset the opposite direction. Right, so I guarantee you're going to have a hard time trying to work out whether or not these two curves are clockwise or not. Let's avoid that. What's another way of working out which one is out and which one is in? Out is what? out is going to have a larger what? A larger area, okay? So we can actually test the area of these two curves, work out which one we want to use to make the floor. Is this making sense? So you can see we're putting some logic in, we're stepping through, we're saying logically we don't need to decide if it's the first one or the second one because we can actually measure its area to define it. Now, I'm going to let you guys take the merge and work out which one you want. I'm not going to code it. I'll do it as slow as I can. Don't watch me. What are we measuring? The area. Unfortunately, Sophie, sometimes you won't find curve. You can't find area in curve. Like if you want to measure the area of a curve, you can't find it in curve because it's actually under surface. That's the only time my little system doesn't work. I'll talk about that very soon. Okay. Have you had a go at it, at least? You've tried? You've tried? Okay, so we should have at least gone to try and get its area, at least, right? That it comes a point where you either you somehow have to work out which one is the highest number in that list, right? So once you've taken the area, you can run those numbers in their branches through a sort list. What sort list does is it takes a list and it sorts it from the lowest number to the highest number. Okay? So what that's going to do is it's going to put the 9 first and then the 12.96 second. And obviously the second list hasn't really changed because it was already in order to begin with. Now the key thing here is when I sort these numbers, we can also sort synchronously other lists. And to demonstrate that, I'm going to need you three. Could you please stand up? Yeah. And come stand in front of the screen. I'm going to assign you guys a number. 1, 10, 100. Now from in this direction, from looking at me, from left to right, I want you to stand in order. You can look at the class. Okay, from left to right, I want you to be in order. So what number were you?
1.
And what number were you? Swap. And that, when I say swap, I meant you two. Keep going. Okay, so what we've done, in our heads, we can quite easily sort 1, 10, and 100. We know 1 is the lowest and 100 is the highest and 10 sits in between, right? But what we've done here is we've then sorted these 3 men synchronously with the number that was appointed to them, okay? So imagine you were curves now, and you were the curve with 1, and you were the curve with 100, and we want the curve with the largest area. Which curve would we pick from this list?
Gary.
Can you? I don't care what his name is. What curve would you pick from this list? Come on, tell me. You need to tell me which curve. No. That's the curve. You're picking the curve with the area of 100. I'm now looking at a list of curves. Which curve? Here's the first curve. The last curve. Right. Okay? And the key thing here is not the third curve, the last curve. Because if I grab these 4 guys and add them to the list, he's no longer the third curve, is he? He's still the last curve though. Okay? So if I were to do it again, if you would help me, I'm going to give these guys more numbers. So you will be minus 50, you will be 2, and you will be 1. I want you to order them.
So minus 50 would go to the left.
So can you follow?
And then is Josh 1?
Yep.
Is that it?
Yep. So what you've done, you sorted those numbers in your head, and then you synchronously moved these guys around. And that's what this component does. You guys can sit down, thank you. Yay. So what it does is we can put the numbers in, and as long as the numbers are in the same list structure as the objects that we want to move around, it will then sort our curves in that same manner. So the smaller curve comes first, and then the larger curve comes second. Obviously, you can't see what their area is here, but we know that's what it's doing. If I test the area once these come out, we will see that always the larger area will be last. Okay? And what was the way that we can choose the last item of any list, any size list? How do we pick the last item of any size list? -1. Brilliant. Good job. Cool. So what that's going to do is it's going to give us the outer curve. Cool? We want to not offset, we want to create a boundary surface and extrude it to make a concrete slab. So let's do that. Put a boundary surface in, put an extrusion, and we'll give that a vector of, now a number that you guys should be remembering for a while, hopefully. A sensible slab size is 150 millimeters minimum, maximum, whatever it needs to be. Okay, but you won't usually see slabs go beyond maybe 300. Okay, so in meters, that's 0.15 to 0.3. And the key thing here is we want this to go down, not up. Okay, huh? It's because if you think about it, yeah, well, we've already gone up with the wall, right? So we want this to go down. Pardon? It's either 0.15 or 0.3. The key thing here is we want it to be a negative vector. So we want to times this by -1. We can either do that by using the negative component, or we could use an expression, whichever way you want. It doesn't really matter. But what the really cool thing here is you can see we've got a slab being built to the edge of our wall. Cool? I know some architects would absolutely kill for this script. It'd be like, what? So yet again, just to hammer that nail in, I draw a closed curve, I get walls, I get a slab. Yeah? Do you understand how, like, every time I add this curve into the system, I am not copying and pasting this script. The script is designed to work with any number of rooms. Okay? If I grab a room and I move it up, the system works with it. Whoa! What the fuck was that? What was that? Was that you throwing stuff around? Oh. Okay. Last thing, ceiling. Works very much like the floor, right? The slab. Yeah? So, but what do we have to do to the curve before we make it a ceiling? If I just take this curve and extrude it up, am I going to get a ceiling? Do we remove it? And do we know how high we need to move it? Do we know
To the length of the wall.
the height of the wall?
Yeah.
Yeah, length of the wall is, yep, height of the wall. So here's the height of the wall. So, and it's already a vector, so we're going to utilize this variable to move this floor curve. So we're going to transform our floor curve up using that z vector. So there we can see it's actually sitting, oops, I only want to do this one. So there it is sitting there. It's a move. And we're just utilizing this, the height. So I'll keep that over here and I'll group that and call that room height. And, then there's only a few more steps to go. Just remember, I'm just grabbing that external curve, not the internal one. We just want to, we could even move the boundary surface so we don't have to do the boundary surface again. And we then extrude that in a positive direction. So we'll get rid of that negative. And I'm happy for that to be, that's positive now. That is a hollow room. So if I do a clipping plane right now, a vertical one, and I cut through my grasshopper model, you can see there's that is a hollow room. Perfect? Sweet. Okay. So, I shouldn't be teaching this to you, this next thing right now, but screw it, let's teach it to you, okay? There is this thing in the world that exists now called BIM. It stands for Building Information Modeling, okay? Now, Autodesk came up with the word, came up with a phrase, slapped it on one of their products called Revit, and they now own that word. Like when you say BIM, everyone thinks Autodesk product Revit, right? But the Europeans here would know that there are other programs out there like ArchiCAD, and there are various other BIM programs out there. It does not belong to Autodesk. And the key thing with BIM is that objects have properties. That's it. That's all BIM really means. Okay? So in the past, when an architect went down, grabbed their pen, went to the drawing board and drew a line, there was nothing defining that as a wall unless they actually labelled it wall, right? And when an architect went and drew a line in AutoCAD in the past, it was just a line that was meant to be printed on paper. If it belonged to the wall layer, we didn't know if it was the outside of a wall, the inside of a wall. It just didn't have the properties assigned to it. It didn't define the material. All that mattered was as long as you hatched it the right color or the right hatch pattern, the builders would know, oh yes, that's made of concrete. What BIM does is it says you can take an object in a CAD program and you can assign it that material. You can say, this is concrete. Or you could say, this is a toilet. Or this is a bedroom. And then whenever you move that room, all the properties that are associated with it move with it. When you cut a section through that wall, it sees that the wall is made of concrete and it assigns that wall a concrete hatch. Does this make sense? It's actually quite obvious. It's just that architects have come from a very manual world and they're starting to learn that you can actually have these properties sit on objects. Now, Rhino is not the best BIM package in the world, but I believe it is BIM. Okay? And the key thing is because you can select objects and assign properties to them. So for example, you're going to have a hard time probably assigning names to things because if you go to an object's properties, you will see that you can actually give it a name. Okay? So I can type any name. I could type bedroom into this, hit enter, and now that's got the name bedroom. Okay? This is very important because once you've named something bedroom, I can actually start affecting it based on what its name is. So if I change this now to studio, do you guys remember off the top of your head how tall the studio had to be? Huh? 2 to 3 stories? Yeah? So I could type studio in here and actually collect its name and make it taller just because it's called studio. And this is inherently the light basic version of BIM. Because if the computer can see, that's a studio and make changes to the room based on that, that's BIM. Would you agree? It's quite contentious because I will sit in meetings where people go, Rhino is not BIM. And I work on projects where...
Well, again, because they think BIM is Revit, and if you tell them that ArchiCAD is BIM, it's Revit.
Yes. So as long as an object is able to store properties in it, it is BIM. Okay? Rhino isn't very good at doing the sections that Revit is capable of doing, but that's a section making tool. It's not BIM. BIM is the knowledge that sits behind all of that in the objects so that when you can cut a section, it knows how to treat that object in that section. So a glass comes out looking like glass and timber comes out looking like timber. Okay? So I've named this studio. What I'm going to do is I'm going to select all the other curves and I'm just going to name them properties. I'm going to name them default. Okay? So I've selected I'll get rid of the clipping plane. I've selected all the curves. I've deselected just one of them. I've named them all default. And then I've selected my curve that I want to be a studio, and I've named that studio. Okay? So, I really shouldn't be teaching you this, but I think it would be good to see where you guys, what you guys get to with it. The curves that come out of my geometry pipeline, I can actually, now you're going to have a hard time with this because human can't do this. You need human to do this. You need human to do this. So sorry. Boot camp. I'll get you help, okay? So human can actually grab the object attributes from Rhino. So with dispatch, I'm going to grab the geometry as it comes out, and with it, we can see here that it's actually giving us all the names of our curves. So we can see studio, and we can see all the defaults. So if I grab this circle and I name it something other than default, let's also make this a studio. We'll have 2. You can see now I've got 2 studios in my list. Cool? So, yes?
How did you get the property window?
Pardon?
How did you get the...
I got it from Human. You can find it in reference. It's the rainbow with a red arrow pointing right. Nick, were you capable of writing names in? Okay, so it will show names. It just won't show layers. Okay. Cool? You good? You know where to find it now?
How did you get the...
This one, it's detail properties. Object properties. It's in Rhino. We're assigning these properties to Rhino objects.
Can you please get that up again? The box.
Can I get what?
That property box.
Okay, like if I maximize Rhino, we can find it under, it's this rainbow wheel here, or you can type properties into the command bar and it will show you the properties panel. Or if you've already got layers up, it should be a tab next to layers.
What did you attach to Human?
I got from Human, there's a component called object attributes.
What is going into
That I got the geometry as after it was dispatched, because we don't want the curves. We don't want the curves that aren't closed. Remember?
Yeah.
Yeah. We could actually plug those curves that aren't closed into into the wall output and still have them make walls, like so. Actually, you probably want to do this. Forget that. We'll work that out later. Key thing is we've got studio and default in a list. Has everyone got studio and default in a list? Sorry, Romany. Sorry.
I've only got one to say studio.
Have you named all of them?
Yeah.
You sure?
I need to recall. Oh, sorry. I must have done it.
Does that make sense?
Makes sense, but I'm not following.
You're not following why we're doing it?
No, like what you do.
Oh, you're behind?
Yeah, because I had an issue, but you spoke about it later, so yeah. About drawing the curves clockwise. and
Right.
clockwise.
Oh. Is this yet again, is this a good, this is good? This is good. Huh? Apart from when, what? Oh, the layers thing. Apart from when I was like, nah. Okay, guys. So what we're going to do is we're going to create a nice little lookup table. We're going to say, in that lookup table, we're going to define the height of things. So we're going to say default, comma, how tall do we want default? We're going to make it 3 meters. 2.5, you want to be mean? Okay, 2.5. And then we're going to type studio, comma, and we'll type 5. Actually, no, let's go 7.5, just to be obvious, okay? We're going to make sure that's multi-line data, and this is super advanced, okay? So I'm not going to completely explain everything here, but I just want to show you what it is. We're going to, this is called text. It could also be referred to as strings. Everyone familiar with doing string operations? Okay. Romney, are you familiar with strings? Tom, are you familiar with strings? You are? You're familiar with strings? Kind of. If I were to ask you to split this text or string up using the comma, what would you get as an outcome? You would get a list of everything after it was split. So there's text split, and you can use characters in text split. So for example, we could use the comma, and the output of that will give us two lists, one with default and 2.5, and the other with studio and 7.5. Cool? So what we're doing is we're just writing like a little CSV. So if we add more commas to this and we say blue and red, then we would get blue and red as a list. So it's a way of writing a list just using commas instead. It's an easy way of typing these lists in. Key thing here is that the first item of each list, so if I use a list item, the first item is always going to be the name, and the second item is going to be the height of the space. Okay? Now here, this is where we want to flatten. This is one of maybe the only times you ever actually want to flatten is here. So everyone's been using flatten, I'm assuming, to fix problems. Yeah? So, if there's a problem, flatten, that will fix it. Not necessarily true, yes?
You slow down and go back to the text split.
Sure. So we're using a... Okay. You will realize why very, very, very soon. Okay? The key thing is we want to use... We could write this another way. So guys, should I write this a different way? I'll write this a different way. What I'm going to do is we're going to write a list of default and studio. Yeah? We're going to write a list of default studio, and in a second list we're going to write 2.5 and 7.5. The key thing is default, 2.5 belongs to default, and 7.5 belongs to studio.
What are the numbers for?
They're going to be the heights of the spaces.
Okay, yeah.
Okay? So defaults is just going to be 2.5 meters high, whilst the studio is going to be 7.5 meters high. Yeah? So here, we've got a list of every space, and it tells us whether or not it's a studio or if it's default. We can use this component here called replace members. What that does is it takes a list, it looks for anything in this list, in here, and replaces it with its corresponding value in the second list. So studio gets replaced with 7.5 and default gets replaced with 2.5. Okay? If I type these wrong, it won't replace them. So if I type studio incorrectly in here, then it's not going to pick it up. It's going to be called studio. Huh?
Didn't think about it.
You don't know about this?
No, I knew that, but actually I didn't think about it now. First time this lesson that I couldn't see what we were.
Oh, where I was going. That's okay. So, we've now got a list of unique heights for each of these rooms. And we've got this slider here that's telling the rooms to be 3.5, all right? So all we'd need to do is put these numbers into the unit Z. But do not do that yet, because let's just make sure here, what have we got? We've got a list of boundary surfaces, and they are what? They're in what type of structure? They're in a branch structure, okay? So we need to make sure that these numbers are in the same branch structure, or otherwise we're going to get mess. So who here had a script when you went to go laser cut it and had like 1 billion lines in it? Right. That is because you were dealing with branches and flat lists, and it was multiplying those things by those flat lists. So for example, let's just plug this in, and hopefully it doesn't crash. What it's doing is it's actually it's using each of these numbers for each of the rooms, okay? So it's using the 9 numbers for the first room. So it's extruding the first room by 7.5, then by 2.5, then by 7.5, then by 2.5, then by 2.5, then by et cetera, et cetera. And then it goes to the second room and it extrudes that by 7.5, then 2.5, then 2. Et cetera. So we just need to make sure that this list is structured in the same way. And the way to do that right now is we can see here that we need a branch per item, and the component that would do that is graft, okay? So that's what graft does. It makes a single branch per item in that list. And we can see that's looking very much like our boundary surface data now, yeah? So we'll just make sure that's simplified just in case. We'll plug it into our unit Z, and you can see here now, my 2 studios are 7.5 meters high, and all the other rooms are 2.5. Cool? So look, if I pick this, and I set this to be a studio, it's now a 7.5 meter high room, and if I now make that default, it's a 2.5 meter high room. If I want to change the height of default, I just come in and change that there, and it makes all the defaults 3 meters high. Let's stop. Let's set in. Time out. There's a lot. It helps so much.
That's cool.
It's very cool.
Yeah.
Right, so just one more thing. Let's say we want to have a really nice kitchen, right? So we just add kitchen in. We'll make kitchen equal 4. Now, if we add kitchen as a name to our curves, kitchen, we've now got a 4 meter high kitchen, okay? So this is extensible. You can make whatever you want with it. The other thing, just remember, this doesn't just have to be room heights. This could be anything. You could define the wall offset by the room type. So the kitchen could have a very thin wall, or the studio could have very thick walls because they need to be solid and strong, right? So this is very, very simple BIM, but it's probably some of the most powerful BIM that you'll have access to right now, because most people using Revit have to go in and actually assign these things manually, right? They have to go in and say, oh, this wall is concrete. You could say all the walls in a kitchen are concrete, and it will automatically do that. Okay? So shall we take a breather? We will address any questions relating to everything that we've just done. Note that this is being recorded. So tonight, I promise, I will put up last week's and this week's tutorial and lecture and start marking. I can't promise that we'll be done by next week, but I promise that I will not lose your marks. Huh?
Good luck is inspiring.
What? With what? Okay, thank you. Yeah. Okay, so this will be up there. Also, you'll be able to download this script from the website. Unfortunately, and I promise I will find you guys some solutions. Yes, hang on, let me just stop recording. Or is it a question that everyone should hear? Huh?
So when I'm adding like a new, I guess, room, right? 'Cause I was drawing it again on Rhino. It just made errors everywhere. I couldn't edit anything.
Okay, that's not necessarily. Let me just stop recording.